Okay, with this quick video segment, we're going to talk about energy conversions. Now remember, the word conversion means to change, okay, from one form to another. So like a butterfly, when it converts from a caterpillar to the adult butterfly. Okay, energy can be changed from one form to another. So if you change it from chemical energy to mechanical energy, changes in the form of energy are called energy conversions. All forms of energy can be converted into other forms. The sun's energy in the solar cells, the nuclear energy there, okay, is converted directly into electricity. Green plants, or plants that go through photosynthesis, convert the sun's energy, which is electromagnetic because it's light, into things of starch called starches and sugar, which to them is chemical energy. Some other energy conversions in a motor, like that powers, I don't know, a blow dryer or any type of electric motor. You have electromagnetic energy from the electricity converted to mechanical energy to power the motor. This happens in your refrigerator. Okay, the electricity that comes in is sent to the motor, and the motor changes that electricity into mechanical energy to move the different parts of the refrigerator to make cold air. In a battery, you have chemical energy is converted into electromagnetic energy. Whenever you turn something on that's battery powered, it changes the chemicals inside that battery into electromagnetic energy. Which, by the way, did you know that Missouri is the leading producer of lead for batteries? Mechanical energy of a waterfall is converted to electrical energy in a generator. We kind of watched this in that Bill Nye. Okay, in an automobile engine, fuel in gasoline or diesel is burned to convert chemical energy. Once that chemical energy is burned, it changes it into heat. So you have chemical energy from the gasoline changed into heat energy, which we call thermal energy. That thermal energy is then changed into mechanical energy. So it causes this to move. I think this is supposed to be an airplane or something. Okay, so we have chemical to heat to mechanical. Okay, states of energy. The most common energy conversion is the conversion between potential and kinetic energy. Now remember, we talked that potential energy is energy, stored energy that has the potential to do something. Kinetic energy is it's actually doing something. Okay? And we just talked about that. Kinetic energy is the energy of motion. Potential is stored energy. So kinetic energy, we call that energy of movement. Kind of like mechanical, but like if you have a treadmill that's off, it has potential mechanical energy. It has the potential to move. When the treadmill is actually on, it's going to have kinetic mechanical energy because it's actually moving. So it has kinetic because it's moving and mechanical because it's moving. The greater the mass of a moving object, the more kinetic energy it has. We talked about this. So it's kind of like the full grocery cart versus the empty one. Kinetic energy depends on both mass and velocity. So how many atoms are in it and how fast and the direction that it's going. Okay, there's your formula. Okay, so what has a greater effect of kinetic energy, mass or velocity, and why? So which one causes more of a change? Change in mass or change in velocity? What do you think? Take a few seconds and ask yourself, what do you think? Okay, potential energy is stored energy. Stored chemically in fuel, the nucleus of atoms, and in foods. Or it's stored because of the work done on it. When you stretch a rubber band, when you wind a watch, when you pull back on a bow's arrow, when you lift a brick high in the air. All of those things have the potential to do something. The brick has the potential to fall. pulling back on an arrow on the bow, on the bow, not the arrow. When you pull on the bow, it has the potential to release and cause the arrow to fly. When you wind a watch, it's getting the potential to start moving again. Okay, now potential energy and gravity. It's dependent on height, or the one that is dependent on height, we call it gravitational potential energy, because the higher it is, the more potential that it has for gravity to affect it. If you have a book sitting on the floor, yes, it has potential energy, but if you have a book sitting on top of a ladder, it has gravitational potential energy, because gravity can cause it to fall and hit the floor. Okay. Energy that's stored due to being stretched or compressed is called elastic potential energy. So think of elastic like a rubber band. A waterfall, a suspension bridge, and a falling snowflake all have gravitational potential energy. If you stand on a 3-meter diving board, you have 3 times the gravitational potential energy, which is what GPE means, than you had on a 1-meter diving board. So the higher you are, the higher your potential energy. The bigger they are, the harder they fall is not just a saying. It's true. Objects with more mass have greater gravitational potential energy. The formula to find gravitational potential energy is weight times height. Okay. So let's talk about roller coasters really fast. We all like them. They're super fun. They go fast, upside down, things like that. Roller coasters work because of energy that's built into their system. Initially, the cars are mechanically pulled up the tallest hill. You know, that first big giant hill you go right out of the loading zone. From that point, the rest of the ride is a basically giant conversion between potential and kinetic energy. So the conversion of those two things is what keeps the car going throughout the entire ride, and why at the very end they have to pretty much jerk you to a stop. Okay, at the maximum point of potential energy, the car has minimum kinetic energy. So over here on the right hand side here, when it's really high up here, you'll notice it's really low down there. Okay, I'll leave this on here for a few seconds and so you can watch. Okay. And you see the speed changes with the height. Okay, we're going to get into all of this stuff. We're going to kind of build a little mini roller coaster. Okay, as a basketball player throws the ball into the air, various energy conversions take place. So here here's where you're starting. Okay, so you would have the little dude down here, okay, or down here, shoots the ball up. Okay, shoots the ball up, so he starts to slow down because you're fighting gravity. And up here at the top where it changes paths, that's where you have the maximum potential. Because for a split second, this ball stops moving. But it has the potential to fall or to move again. So as it starts to switch directions, it starts to speed back up because gravity is kicking in. As it has speed back up, down here at the bottom, you have maximum kinetic energy. So it's fully moving at that point in time. Okay, there's a very important law in science called the law of conservation of energy, which says energy can be neither created nor destroyed by ordinary means. That means you cannot make it, you cannot get rid of it. So it doesn't poof, come out of nowhere like a magician's wand, and it doesn't poof, disappear like a magician's wand. It can only be converted from one form to another. If energy seems to disappear, then scientists look for it, leading to many important discoveries. This is one of the things that led them to discover black holes. or that thing called antimatter or dark matter now that they're doing some research on. Okay? It does not go away. And a law in science is something that has been not proven, but supported by thousands, if not millions, of scientific experiments over the years that has said, yes, energy cannot be created or it cannot be destroyed. We agree this is a true statement. Okay. In 1905, a very, very, very talented scientist named Albert Einstein said that mass and energy can be converted into each other. Okay, which is kind of a big deal. So saying the number of atoms and energy can be converted. He showed that if matter is destroyed, energy is created, and if energy is destroyed, mass is created, which is this whole E equals mc squared. It's not just a goofy little bunch of letters all stuck together. Okay. All right, so these are all the vocabulary words that we talked about in this section. You should know what all of these mean, okay, and be able to discuss them in a professional way. All right, thank you very much.